Hello everyone. In this video, I am going to discuss linear algebra, which is helpful for CSIR net and as well as Karnataka set exam. In this video, we will see the eigenvalue of the matrix as well as eigenvector of the matrix and characteristic equation of the matrix. How to find eigenvalue and eigenvector of the matrix. We start this video with the help of an example of the 2 cross 2 matrix. Find the eigenvalue and eigenvector of the matrix 3, 1, 2, 2. Here the given matrix that is A equal to that A matrix is 3, 1, 2 and 2. Firstly, we have to find the characteristic equation of the matrix. This matrix is of order 2 cross 2. 2 cross 2 matrix characteristic equation is shortcut method CH of A, which means characteristic equation of the matrix A, that is equal to lambda square minus trace of matrix A into lambda plus determinant of the matrix. This is the characteristic equation of the 2 cross 2 matrix. Here lambda square minus trace is the sum of the diagonal element, that is 3 plus 2. Here diagonal elements are 3 and 2. This sum is 5. Hence the trace of this matrix is 5 lambda. And next, determinant of the matrix. Determinant of this matrix is 3 into 2, that is 6, minus 2 into 1, that is 2, 6 minus 2, that is equal to 4. This matrix determinant is 4. This is the characteristic equation of the matrix, lambda square minus 5 lambda plus 4. Here by Cayley-Hamilton theorem, its characteristic equation is satisfy the matrix, that is equal to 0. We have to equate the characteristic equation to 0 to find its eigenvalue. Next we have to factor this one, lambda square minus 5 lambda plus 4. By factorization we can write it as lambda square minus 4 lambda minus lambda plus 4, that is equal to 0, and take in this lambda common, lambda minus 4, here minus lambda plus lambda, you have to take here minus 1 as common, then plus lambda minus 4, that is equal to 0. Then here lambda minus 4 into lambda minus 1 will be the factors. Lambda minus 4 into lambda minus 1 will be the factors of this characteristic equation. Then its eigenvalue will be lambda minus 1 equal to 0 and lambda minus 4 equal to 0. Then lambda equal to 1 and lambda is equal to minus 1, lambda is equal to 4. These are the two are the eigenvalue of this matrix. Hence the eigenvalues are eigenvalues are 1 and 4. Next we have to find the eigenvector of the matrix. To find the eigenvector of the matrix, To find the eigenvector of the matrix, for lambda equal to 1, the eigenvector is lambda equal to 1, eigenvector, that is put lambda equal to, here eigenvector is lambda equal to 1, diagonal, which means a minus lambda I, its determinant, into x equal to 0. A is the given matrix, that is 3, 1, 2 and 2, and minus lambda into lambda is the eigenvector, eigenvalue, that is lambda is equal to 1. Next, I is the identity matrix of 2 cross 2. Then lambda into I will be 2, 0, 0, 2. Then 3 minus 2, that is 1, and here is also 1, and 2 minus 0, that is 2. Here 1 second, lambda value is 1. For lambda equal to 1, that's lambda into I means same as the identity matrix, 1, 0, 0 and 1. Subtract A minus this identity matrix, 3 minus 1, that is 2, 1 minus 0, 1, 2 minus 0, 2, 2 minus 1, that is 1. This is the resulting matrix. Then we have A minus lambda is value is 2, matrix 2, 1, 2, 1. Hence 2, 1, 2, 1, we have to write that matrix, and into its vector, that is x, we have to write x as x1, x2 column vector, that is equal to 0, means this matrix is 2 cross 2, hence we have to take 2 zeros. Here we have to make this equation first, multiply this 2, 1, 2, 1 matrix with the corresponding eigenvector x1, x2, that equals to 0, 0. For this 2 into x1, that is 2x1, plus 1 into x2, that is x2, this is equal to 0. Now again the same equation will be formed, 2 into x1, that is 2x1, plus 1 into x2, that is x2, x2 equal to 0. This equation, same equation will be formed. Hence here we have to assume the value, that is x2 is equal to, x2 equal to 2k. Here x1's coefficient is 2, hence x2 can be taken it as a 2 times of k. K is some constant. Then we have to put this x2 value in this first equation. Both are same equation, we have to put it in any one equation. I'll make it in the second. That is, our equation is 2x2 that is 2x1 plus x2 equal to 0. Let x2 equal to 2k, then 2x1 equal to minus x2, that is 2x1 equal to minus 2k. Hence 2 to cancel, then x1 value is minus k. Hence the eigenvectors are for lambda equal to 1 x1 comma x2, x1 x2 equal to x1 value is minus k, x1 value is minus k, and x2 value is 2k. Here we have to take one common k common, then remaining value is minus 1 and 2, which implies that minus 1 and 2 are the eigenvectors for lambda equal to 1. And next for lambda equal to second eigenvalue, that is lambda 2 equal to eigenvector for lambda is equal to 4. We have to directly subtract this lambda 4 in the given A matrix in diagonal form, that is A minus 4i into x equal to 0 in this way. That is 4i means I is identity matrix. Identity matrix is into 4 is equal to 4 0 0 4, and the A matrix is 3 1 2 2, hence 3 minus 4, 3 minus 4 that is minus 1, 3 minus 4 that is minus 1, and again 1 here. Next also 2 is here. Next 2 minus 4 that is minus 2. This will be the A minus 4i matrix. In the x1 x2 column vector can be written, that is equal to 0 and 0. Here we have to equate this equation first. Minus 1 into x1 that is minus x1, 1 into x2 that is x2 equal to this 0. And also second equation will be the again same, that is 2 into x1 plus here minus is there, minus 2 into the x2 that is minus 2x2. Both equation will be the same. There is no, we have to assume this equation as here minus x1 plus x2 equal to 0, that implies x1 equal to x2. Both have the x1 and x2, both eigenvectors are same. Hence we have to take both as k, or x1 x2 as k, then x1 value is also k. Then its eigenvectors are x1 comma x2 can be written as x1 is also k, x2 is also k. Then k can be taken as common outside, then remaining is 1 and 1. Here one trick is there. What is that? The matrix is A equal to 3 1 2 and 2. Here its row sum is 4, and 3 plus 1 4, that is 2 plus 1 4, which implies that the 4 is the eigenvalue of this matrix. When the row sum is equal, then 4 is the eigenvalue of this matrix. This corresponding eigenvector of this lambda equal to 4 is be 1 and 1. This is the result. When row sum will be the same, then its corresponding eigenvector will be 1 and 1. In this way, you have to find the eigenvector and eigenvalue of the matrix. So we see here a 2 cross 2 matrix. Next we move on to the 3 cross 3 matrix. How to find the eigenvalue of the 3 cross 3 matrix? Here is one matrix. Find the eigenvalue of the matrix 1 2 minus 1 2 minus 1 3 3 1 3 1 2. Firstly we have to write its characteristic equation is CHA. Here is also one shortcut method. Characteristic equation is, that is lambda cube for 3 cross 3 matrix minus trace of A into lambda square plus m11 plus m22 plus m33 into lambda. Next minus determinant of A. This is the trick to find the characteristic equation of the 3 cross 3 matrix. Here firstly we have to see what is the trace of this matrix. Trace is sum of these elements, diagonal sum, that is 1 minus 1 0, that is equal to 2, hence the trace is 2. And next m11 plus m22 plus m33, sum of the diagonal minor, that is equal to m. Firstly we have to see m11. M11 means first row and first column element is this. First row and first column element, this is, then we have to delete the corresponding row and corresponding column. Then remaining matrix can be, we have to write here minus 1, 3, 1 and 2. Its value, that is equal to minus 1 into 2, that is minus 2, 3 into 1, that is minus 3, that is minus 5. Next we have to see m22. What is the value of m22? M22 means second row and second column. Second row, second column means this element, minus 1 element. This is A22 element. Hence we have to delete corresponding row as well as column. Then remaining matrix we have to write. That is 1 minus 1, 1 minus 1, next 3 and 2. Next its determinant is 1 into 2, 2 minus 3 into minus 1, that is plus 3, that is equal to plus 5. Next we have to write m33, diagonal sum of m33. M33 element, which is this, M33 means this element, third row and third column element, here this element. Next we have to delete this row, this column and this row. Next remaining matrix can be take to the calculation, 1, 2, 2 minus 1, and its determinant value is 1 into minus 1, that is minus 1. Next minus 2 into 2, that is 4, and total minus 1 minus 4, that is equal to minus 5. Next sum of this, which is equal to minus 5 plus 5, 0, that is equal to remaining only 5. Next we have to find the determinant of this matrix. Determinant of this matrix, its determinant is, I am right directly, its determinant value is its determinant value is 0, and we have to put all these values in the characteristic equation to get the eigenvalue of this matrix. In finally, remaining trace and diagonal sum value and determinant value should be put in the lambda cube minus trace of a lambda square plus m1 m11 plus m22 plus m33 lambda minus determinant of a, in this characteristic equation formula to find the its eigenvalue. The final characteristic equation will be lambda cube minus 2 lambda square minus 5 lambda, and its determinant is 0, so we avoid that one and equate this equation to 0 to get the eigenvalue. Take here lambda common. If you take the lambda common, then remaining is lambda square minus 2 lambda minus 5. Lambda into bracket lambda square minus 2 lambda minus 5 is the factor, and here in this equation lambda equal to 0 will be the first eigenvalue, and remaining lambda square minus 2 lambda minus 5. For this we have to use the square root formula to find the root formula, that is of the quadratic equation minus b, that is minus of minus 2 plus or minus b square, that is minus 2 square, that is 4. Next minus 4 into ac, that is 1 into c minus 5 whole divided by 2a, that is 2 into 1. Hence here minus of minus 2, that is plus 2 plus or minus 4 minus into minus, that is plus 4 into 5 20 whole divided by 2. Next that is equal to 2 plus or minus root 24 divided by 2. Finally 2 plus or minus root 24 can be written as 4 root 6 divided by 2. Hence 2 can be cancelled. Here we have to take 2 common, then 1 plus or minus 2 root 6. One second, here 4 into 6, that is here we have to write it as 2. This is 2. Then here 2 cannot come with, when we take the 2 as common, divided by 2, 2 get cancels, and its roots are 1 plus or minus root 6. One lambda 1 is 0, and second eigenvalue lambda 2 is 1 plus root 6, and third eigenvalue lambda 3, that is 1 minus root 6. In this way we can find the eigenvalue and eigenvector of the matrix. Here we have to find the its I will do one for lambda equal to 0, how to find its eigenvector. For lambda equal to 0, its eigenvector is lambda equal to 0, eigenvector is subtract the given matrix by 0 eigenvector in diagonally, it is a minus lambda I into x equal to 0. In this way, if 0 can be subtracted, then 0, then matrix will be the same, that is 1 minus 0, that is 1, and 2 and minus 1, and 2 minus 1 3, 2 minus 1 3, and next 3 1 2. into, this is 3 cross 3 matrix. The column eigenvector can be taken as x1, x2, x3 is equal to 0 and 0, 0. Here we have to firstly we have to reduce this matrix by using row operations. Then we have to equate the equation. Otherwise, this will be the big equation. Then we face the problem for solving. Hence, first we have to reduce this equation. 2, 1, 2 minus 1. Here make this 2 as 0 with the help of this row. That is equal to R2 is equal to R2 minus 2R1. We have to use this operation in the place of R2, R2 minus 2R1. Multiply whole R1 by 2 and subtract it from R2. Then 2 minus 2, that is 0. Next minus 1 minus 2 into 2, that is 4. That is equal to, here 0. 1 second. This will be 0 because 2 minus 2, this 0. Minus 1 minus 4, that is minus 5. Next 3 minus here minus 1 into 2, that is minus 2, that is equal to 5. Here 5. Again in R3, row R3 can be replaced as R3 minus 3R1. R3 minus 3R1 to make this as 0. Here 0. 1 minus 1 minus 2 into 3, that is 6. That is minus 5. Here 2 is this. 2 minus of minus 3. That is equal to 2 plus 3. That is 5. Here we have to write it as a 5. Then we have to use another operation. Here see here identical rows for this 1, 2, 1 and 0 minus 5, 5. Here R3 equal to R3 minus R2. This operation can be used to make the third row 0. Hence this is 0, this will be 0 and this will be 0. Hence we have to make this as an easy calculation by using the row operations. Next, the reduced matrix will be 1, 2, 1, 0, minus 5, 5, 0, 0, 0. Then its eigenvectors x1, x2, x3, 3 eigenvectors has to come, that is equal to 0, 0, 0. Here in the next slide I write the equations. The first equation is 1x1, 2x2 r. We have to take this is as minus 5x2 plus 5x3. First equation is minus 5x2 plus 5x3 equal to 0, which implies that x2 equal to x3. Next, another one equation is, here see here we have to multiply as this first row into this vector and equate with equal to 0, that is 1x1 plus 2x2 plus 1x3 equal to 0. This is the another one equation, 1x1, that is x1 plus 2x2 plus x1 plus 2x2 plus x3 equal to 0. Here these two values are equal, x1 x2 equal to x3, then we have to take x1 as k, because these values cannot be find. We have to choose x1 as k, then substitute x1 in this equation as well as x2 and x3 value. Here x1 plus 2x2 plus x3 is equal to 0. Let x1 equal to k. x1 value is k here plus 2x2. Here x3 is there. In place of x3, I can write it as x2, because x2 and x3 both are equal, hence equal to 0. One second, there is some mistake here. Here minus 1 is there, I forget that, minus 1. Here which implies that minus x3, this is minus, this is minus. So finally x plus 2x2 minus x2, which is equal to x2, that is equal to 0, which implies that x2 is equal to minus k. Here we got all the eigenvalue. x2 equal to minus k means x2 and x3 both are equal. They both are equal to minus k value. Then the eigenvectors are that is x1, x2, x3, that is equal to x1 value is we taken it as a k, x2 is minus k, and x3 is also minus k. We have to take k as a common, then 1 minus 1 minus 1 will be the its eigenvalue for lambda equal to 0. And you have also to, and you can do the remaining lambda value for 1 plus root 6 and 1 minus root 6. Hence in this video we discussed about the eigenvalue and eigenvector of the matrix. Any doubt regarding this, comment in the comment section below, and follow my YouTube channel and share this video to your friends, and I will make the next video soon. Thank you all.